A very good afternoon, friends. Warm welcome to the first webinar of the Healthcare Engineering Forum. This forum is all for networking and upgrading oneself with the latest technologies and techniques, knowledge enhancement, sharing and learning best practices from hospitals, enhancing performance of existing systems, ensuring better quality engineering systems, and most importantly, the focus on patient safety. To join this forum, the engineers shall be a life member of CAHO and can write to us at office@caho.in. This is the first free webinar of this forum, and the topic is operation and maintenance of AHUs in OT and critical areas. The moderator for this session is Mr. Arul Prakash. He is the co-chair Healthcare Engineers Forum, CAHO, Associate Superintendent Engineer, CMC Vellore. Sir leads the Central Biomedical Engineering Department of CMC Vellore and is involved in the biomedical equipment management. He has been the key personnel in computerizing all activities related to all engineering departments in CMC. Over to you, sir.
Thanks, Meenakshi, for the introduction. And once again, I extend a very warm welcome to all the participants. For today's session, the speaker is Mr. Vinod Kumar, and the topic is going to talk is about operation and maintenance of air handling units in operation theaters and critical areas. I am very happy to introduce Mr. Vinod Kumar, who is the chairperson of Healthcare Engineers Forum, CAHO. He is a member and resource personnel of CAHO. At present, he is the head consultant at VBG Consulting Engineers in MEP Design Consultancy and Project Management Consultancy. He is also the consultant for engineering, maintenance and safety at Rajagiri Hospital, Aluva, Kerala. He was also the senior operations head for India and Sri Lanka at CKR Consulting Engineers, Chennai, during the period 2012 and 14. And Mr. Vinod has a very rich experience in consultancy, projects, design, operation, and maintenance of various engineering facilities, including the HVA systems in hospitals. Now I am handing over the session to Mr. Vinod.
Thank you, Meenakshi, and thank you, Arul. It's a pleasure to be on board this session, the first webinar session for the Engineers Forum. And we start with our HVAC part, HVAC, heating, ventilation, air conditioning systems. So let's go ahead and talk about the AHUs. Good evening, one and all. Let's see what air handling units are, how the design of or the construction of an air handling unit is going to be, and how do you select them, what are the criteria in selecting, how do you operate and maintain them. And these are air handlers which are specific for healthcare industry. Any commercial air conditioning or air handlers cannot be used for a normal healthcare industry, because the construction of the air handling unit for a commercial application is different to that of a healthcare application, because there are stringent methods of stringent standards that are basically set up in the manufacturing of those healthcare air handlers, which is also similar to that of air handlers used in pharma industry. So coming to air handlers and air conditioning, let's go through a quote from Florence Nightingale. The very first requirement in a hospital is that it should do the sick no harm. All right. So do we have a role to play in controlling the infections inside a hospital as engineers or technical people who are handling the facility management and safety? Yes, we do have. Patients' harm in a hospital can be a result of many. One of them is medical errors, physical injuries, accidents, and hospital-acquired infections. Here we come with our air handlers, which control the environment inside your air-conditioned space, and specifically in all critical areas such as the ICUs or the operation theaters. The air handlers are the prime controlling equipments for the environmental control in all these spaces. Hence, we stand to play a major role in controlling these infections with the right product, the right kind of operation, and as well as right kind of maintenance of the system. What is more important is that the design is to be very critical when you start with the project. And if the design is perfect, then the first step is cleared. You go in for the right selection of the air handlers and have the right team to assemble and install them. And when you operate and maintain correctly, you get the best output of the air handlers. Many a times we see mistakes happening right from the design stage, right from the selection of the air handlers, the installation, as well as operation maintenance. So you have to you have to always keep in mind that you have a vulnerable status inside these critical areas like the hospital, the ICUs or the OTs, because if you miss any of these, whatever I've just said, the vulnerability is going to be very large. And as long as you don't maintain them, you're going to have a problem with the environment inside the critical areas. We specifically talk about critical areas because the selection is important for us to see that you have the right system for the critical spaces in the hospital. Another important thing is whatever you do with reference to your selection, the design, then the correct installation or correct operation, it finally ends up in giving the patient safety and also staff safety. And when you see that the selections of the equipments that are for these areas are based upon standards, they are based upon, they are having certifications in those respective areas of each and every equipment that is part of your air handlers, then you should have the right type of manpower, the right type of people to handle the maintenance and operations of the air handlers in the respective areas of your hospital. And the ability to change. What do you mean by ability to change? We all have seen in many places the maintenance of all these systems are literally not done correctly, or there is a lethargy in doing the maintenance. Let's all think about and go for a change. Yes, we need to maintain them correctly. Buying the right product is not enough, but we need to operate and maintain them correctly. So this is the tendency of us, that the tendency should be that we should be able to change from what we are to what we should be. So as I go through this slide, you will come to see how you'll design, how do you operate, and how do you maintain it. And then you will see that we all have to change in the sense that we maintain them correctly so that it delivers what it has to deliver. I follow the standards that are mandatory for the selections of air handlers and also for the selecting of vendors or even the state of installation or commissioning. So we follow basically the air conditioning standards called as AHU, the American Society for Heating, Refrigeration, Air Conditioning. Then we also have the the HTM standard from Australia, NABH, FGI, Facilities Guidelines Institute from USA, NFPA guidelines, and the UL standards for selecting the various parts of the air handlers that come into your building. Coming to air handlers, generally we have two kinds of air handlers. One, a single-use air handler, and the other one is a recirculation air handler. The olden days, we have seen operation theaters where the air handlers are 100% fresh air handlers. What do you mean by that? Air handler, which is 100% fresh air AHU, is basically taking in fresh air from outside. It's filtering the air, cooling, and then putting the air into the theaters. And the entire air is then extracted and discarded outside. So the air is only used in the theater or the ICU only once. So this becomes a single-use air handler. But things have changed over the years. It's a very good system because it has the highest level of contamination control as compared to the second type of AHU, which we call it as the recirculation AHU. But in the end of the day, you need to save energy because 100% fresh air systems are very high in the cooling loads as compared to the recirculation AHUs. So over the period of years, number of studies have happened and they have come across the kind of recirculation AHUs that has to be used in the various kinds of application in the hospital. Various kinds I'm trying to say is you have operating room, you have ICUs, you have bone marrow transplant rooms, you have various kinds of usages are there. Accordingly, your fresh air intake into the air handlers are being modulated to meet the requirements of the air control in the respective area. So we call them as recirculating AHUs, where return air is taken back to the AHU, which is then mixed with a percentage of fresh air, and then it gets cooled and treated. It goes into the space, which is the OT or the ICU. So this is what we generally see nowadays with a kind of AHU. We call it as a recirculation AHU, which has an arrangement of fresh air which is coming into the AHU and then it gets into the system. There are treated fresh air AHUs dedicatedly used in many places, which is another good way of using that. You have a AHU which takes fresh air needed for the areas, and then it gives the fresh air treated into all the other recirculating AHUs. So this is also a good method of having a 100% fresh air AHU giving treated fresh air to all the recirculating AHUs. Now I'm going deeper into the technicalities of the AHUs. How do you select the AHUs? How the AHUs construction should be? The AHUs construction for a healthcare system is very specific as far as ASHRAE guidelines are concerned. So we have to be making sure that you set up your design standards, your specifications very clear even before you start purchasing, because what you get from the market could be a simple dabba, a box which just delivers air and cooling. It is not going to be that simple, because the healthcare AHUs are supposed to be following a set standards as what I will be going through in the next few slides. So the standard, the unit capacity, then there are various things that we need to look at in the selection of the AHU. So these AHUs are being made by various vendors, and each part of the AHU has different ratings and standards that are mandatory. For example, the unit capacity. When I say the capacity of an OT AHU is 10 tons, it has to be, the capacity has to be calculated and the unit selected according to the AHRI standards or the EN standards according to the position or the manufacturing facility wherever they are located, or the standards what they follow. Some of them follow the British standards, some of them follow the European, and some of them the American standards. So we have to see what standards the manufacturer is following and the capacity. When I say 10 tons, I need to get 10 tons. Is it certified? Yes, the calculations and the selection of the AHU should be certified for it. Next important thing is, when you have AHUs running, you feel a big noise coming from their handlers. Now, we can't have noise, because noise control is going to be an important part, especially in critical areas in the theater or in the ICUs. A doctor telling or giving instruction to the nurse, or a doctor giving an instruction to a technician has to be well heard. There should be a sound which is acceptable, and then the manufacturers have to follow their standards of ISO 9614. Similarly, when you come to the AHU's construction, it's a big box, and the box has a casing. The outside casing is supposed to be following as per the BS-EN 1886. These standards are to be set up in your standards or your specifications, which you will be issuing to your vendor before you select the product. Secondly, what is this? Coming back to the casing, why it is important to be following this standard is because many of the air handlers which you will be looking will have lot of condensation on top of them, water droplets on the outside of the air handlers. You can, if this air handler is installed inside the ceiling above your head, there will be water dripping onto your head or on the floor. So the casing is important, not only for the the strength of the air handlers, but also to see that the thickness of the casing is appropriate in line with the standards. Similarly, the fire protection category, we categorize it as A1. All the air handlers that we have to use in a hospital should be double-skinned air handlers. Double-skinned in the sense, the casing will be having an outer casing and an inner casing. And in between the two casings, you have insulation. This insulation is actually going to control the heat transfer from outside to inside, and thereby help you to maintain your temperatures for the respective areas where the AHU is feeding. At the same time, it will help control your condensation on the air handler. So you can imagine that there are many places the AHUs are not having a casing which is double skin. It's just a single skin. Single skin, there's a lot of energy loss. There is going to be temperature loss as well as condensation, which is going to be a perennial headache for the organization. So The criteria is that you need to have a double skin AHU. Now look at the double skin AHU construction. The outer skin has to be of 0.8 mm thickness, and the inner skin has to be of 1 mm thickness. And that is the construction that we talk about, is how sturdy the AHU is going to be. This is the guidelines as issued by AHU. So I'm giving you the standards which you can actually copy it into your tender specifications, or your consultants who you have employed are made to use these standards in your selections. And if you look at the inner skin, has to have a zinc coating, which is up to 270 GSM, because this zinc coating actually is to keep away the corrosion inside the AHU. See, corrosion inside the AHU can never be seen. If you look at an AHU, the moment it is switched on, it is going to run forever. You will never be switching off the AHU. Nobody will go into the AHU to see this. Hence, it's important to make sure that you select the AHU with this correct kind of a skin. The inner skin should have a coating. This 270 grains per square millimeters of zinc coating will not allow corrosion to happen. That is a prime factor about this. Okay. Similarly, the outside skin should have a polyester paint of, it's a pre-coated skin, so that you don't have any kind of corrosion. Painting is generally done to avoid corrosion. So basically, they are all of that category. Okay. Now coming to the last line which I have shown here is thermal bridging factor. It's an important factor that you as engineers or doctors or owners should make sure that the AHU is following or is in conformance to this particular factor. This thermal bridging factor is basically to confirm that there is no condensation. When does things condense? Because there is something cold on one side and something hot on the other side, and then you have a metallic surface where you have a kind of condensation happening because of the temperature difference happening, and when dissimilar metals are touching to each other. So you have to have a classification of this casing where we call it as TB2. That TB2 actually makes it as a thermal bridging. You create a thermal bridge which avoids this connection between the cold and the hot, or the low humidity and the high humid air, high temperature and low temperature air. Thereby, this anti-condensation really happens. So it's an important factor of TB2 in your selections. Then coming to T2. T2 is another classification. What is this classification? This classification is basically to make sure that there is the heat transmittance from the outside of the AHU to the inside is the most minimum. Okay. So the classification of your AHU has to be following that of T2. This happens when you're having the correct kind of casing, which I just said before, the inner casing, the outer casing, and the insulation in the middle. You look at the last line. Between these two casings, you will put the insulation. So the AHU comes with a double skinned panel with an insulation minimum of 45 mm thick, and that insulation can be of various categories. It could be fiberglass, rock wool, or it could be even polyurethane puff kind of insulation that can be injected in the gap between the two panels. And its criteria is that it should be a minimum 45 mm thick, and the density of the insulation at least 48 kg per cubic meter. And here the total thermal insulation value, once you set up the panel, the vendor has to confirm that it gives you a minimum of 0.22 watt per meter square Kelvin. This is the U value. U value is the thermal insulation value of that panel in totality. I did mention about the inner skin, the outer skin, the insulation in the middle, the thickness of both the skins, what is the thickness of insulation, what is the density of insulation. I think I'm going step by step to tell you how the construction makes it efficient enough to give you the right kind of environment in your theaters or the ICUs. It's a material. You have a mall or a showroom or a shop, wherever there, you don't have these criteria because it's just air conditioning. There is no, contamination control there. It's just cooling, cooling, cooling. That's it. But we should not be talking the same category of saying cooling in my theater, cooling in my ICU. No, it is air conditioning where you have the temperature, your humidity, the air filtration, and above all, the positive pressure that you maintain. So the whole sequence, once I finish the specifications of the AHU, you will understand that how important it is for you to select your air handlers of this construction. Now, the AHU panels are having a fan, the AHUs are having a big fan or blower inside them, and it's pushing the air into your theater or the ICU. So there's a lot of pressure that's happening. So the equipment manufacturer has to make sure that the system, the AHU panels, don't crack in or crack outside because of the pressure. The pressure the panel construction of the AHU should be able to maintain a pressure up to 200 Pascal, as well as the framework of the AHU should be such a way that it is strong enough, minimum thickness of 4 mm to 6 mm, and the height of the frame around the base of the AHU should be 80 millimeters. And now look at the AHU, you will have to have access doors which will actually give you the access to the internal parts of the AHU. So you have to, as a vendor, as a client, you should tell the vendor the access door positions and how the AHU can be maintained. If you don't have correct kind of access doors or removable access panels, you will not be able to maintain the AHU. Similarly, when you install the AHU close to the walls, obviously you will not have space for opening these access doors, even if the access doors are inbuilt on the AHU. So it's mandatory that when you select the AHUs and design it and give it for the manufacturer to manufacture, your AHU rooms should be bigger enough to house the AHUs, plus access for the access doors to be opened up so that the technicians can go into the AHU to actually monitor and do maintenance as important as possible. Secondly, the doors should be having enough rubberized seal so that they don't leak. Now, if I say, if after this session, if you could go and check any of the AHU rooms, you can see air leaking out of the AHUs. It's basically, the problem is that between different sections of the AHUs where this thermal bridging is not done, where the sealant is not correct, plus wherever access doors or removable panels are there, those sealants are not there, which means you're going to lose a lot of cold air which is treated. At the same time, it will also take air from outside if it's kept on the terrace or in a place where it is very dirty. So what is important is the doors, which we call it as accessible doors or removable panels, it should be actually going to be with rubberized seal so that it's airtight when it's closed or when it is under operating conditions. Now, the door is important, but at the same time, when the AHU is running, the door should not be openable. If you open the door by mistake when the AHU is running, it's going to be a problem because it will be a safety issue for the maintenance person. So the AHU fan should actually switch off or trip when you open the door. So many of the places this cannot be seen because it's never been told to the vendor, and the vendor doesn't give it because it's a cost for him. So there is a tripping mechanism for the AHU fan motor when you open the door when it is functioning. When you switch off the AHU for maintenance, it's fine. But what happens is the technician, in his pressure to handle the problem, he would forget to actually switch off the main switch or the isolator, and he will just go and open the AHU without knowing that the AHU is running or without knowing that the isolator has not been switched off. This is going to be a serious risk factor for the technician. So it's mandatory to interlock the AHU with the motor. Now, coming to the most important part of the AHU is the fan. There are various kinds of fans. Now, many people, when they select the AHUs, they select the lower costed fans. Now, is it the right fan? It may not be. Why? Because there are two kinds of fans or impellers, the forward curve and the backward curve. These forward curved fans are actually selected for AHUs when the pressure, the total pressure is below 700 pascals. That's very important because when the AHU is selected for pressure levels of more than 700, it should be backward curve because this is going to create a lot of noise and also will not be able to maintain the pressure that you really need for the air to reach your last grill or the diffuser, because the air has to come Either it should, if it's an operation theater, the air has to come through the plenum and come into the space. So if the pressure levels are not correct, because the fan is selected wrong, you will not be able to get the air correctly. So you can say, I've heard clients saying, Vinod sir, the AHU has been commissioned, the air is not coming at all. Hawa nahi aata hai. There is a problem. Now the problem is the fan has to be changed. Now the AHU is installed, it is running. Now to change this fan, you have to go to the manufacturer once again. Until such time the fan comes, you will not be able to get the air. So you can imagine the kind of pressure the hospital will go through because you have a problem with the AHU. So this fan again, not only the type of fan is important, the fan are generally tested for BS standards or AMCA standards. BS standards are basically the British standards and AMCA is basically the American standards for the air performance of these fans or impellers or for the total sound performance. It's important. Now when the fans work, what happens? They vibrate. So you need to have vibration isolators. The vibration isolated springs, generally, you should put a minimum of 25 mm, depending upon the kind of air or the kind of the blower or the impeller is going to be. Now the fan has to have bearings, obviously. These bearings supposed to have fully sealed for life bearings and at least able to run for 200,000 hours or 2 lakh hours of running hours, because the bearings, if you see, you can check with your technicians, they would be changing the bearings every now and then because there is a noise issue, there is a load issue. Now, why is it? Because the fan bearings have not been selected correctly. So if you have a spec like this in your tender, it will make, you will make sure that the AHU comes with fan bearings which are long life. That's very important. The next important part of the AHU is the chilled water coil or the DX coil. Now the coil is again the one where the refrigerant gas passes through or the chilled water passes through. What happens when the cold water or cold refrigerant passes through the coil? It starts cooling the air. So now you got the process. I have started the casing, the construction of the casing, coming to the AHU. Then we look at the fan impeller. Now we move into the next part of the cooling coil, we call it, and that has to be AHRI rated. Now the cooling coil is comprising of copper tubes and fins. Now here again, the vendors, they go for low cost copper tubes which are lesser in thickness, and the number of fins are also spaced at a wider space. The spacing of the fins as well as the copper tubes enhances your AHU performance in terms of giving you the correct cooling or adequate cooling, at the same time not wasting energy. If your coil is not correct, what happens? The cold refrigerant or the cold water will come and go. Heat exchange will not happen. Now, what is the actual intention of heat exchange? The heat exchange is basically to cool the air. That cold air has to come to your premises, which is your theater or ICU. Now, if the coil is wrongly sized, the copper tubes and fins are not exactly as per the requirements, it will not perform. The water or the refrigerant gas which is cool will come and go without giving its chillness to the air. Now what happens in the process? You are not going to get the correct temperature inside your space, which is the OT or the ICU. So here the vendor, the specialist AHU vendor should make sure his coil performance is set to BS standards or AHRI or Eurovind standards. Okay, and very important is the coil, since it carries water or it carries refrigerant gas, it has to be factory tested for pressure, factory pressure tested before it is actually brought to your system. At the same time, you'll have to gain pressure test on site so that you can ensure that there is no water leakage. Now, when I said air is passing through the coil to cool, we have to maintain a kind of velocity. What is the velocity of air that you will maintain through the coil? You have to maintain up to a maximum of 2.2 meters per second of velocity. The air passes through the coil at a maximum of 2.2 or not more than 2.5 meters per second, because if the air goes at a higher velocity, it will carry water along with it. Now, where does the water come from? The water comes from the coil itself. How does the water come from? Now, imagine you're taking the air through the coil. The air has got a lot of humidity in it. Now, the moment the air touches the coil, which is cold, the water vapor in the air starts condensing and starts dripping as water droplets into the drain pan. As such, what happens? The water gets carried forward and it goes into the theater, spoils your HEPA filters and makes it messy situation with fungus growth in the HEPA filters or water dripping inside the grill. So you have to make sure that the selection is of the right velocity. Here again, this specification talks about what is the thickness of the tube as well as the fin thickness, which is important for the selection. So you get the right kind of a copper tube inside your coil. And as the water condensation happens in the coil, you should have proper drain pan, and the drain pan will be connected to the drain pipe. Now here the drain pipe has to have a proper U-trap. The trap selection is also very important, because if the trap is not selected properly, the water inside the drain pan will never get drained. And if it gets stuck in the drain pan for long, the air takes the water and puts the water into your laminar plenum where the HEPA is there. So it's important that each AHU will have a drain pipe with a U-trap. The size of the trap is actually calculated with a minimum of 1.5 times the negative static pressure. Now coming to the last part of the item in the AHU is the filters. Generally, for such applications, the AHU will have the pre-filter and the back filter, or the fine filter as we call it. The categories are EU4 and EU9, or G4 or G9 according to the manufacturer's standards. But this is what is standard as specified by ASHRAE 52.1 EN779. And here again, the filter selection should be for not more than a velocity of air passing through that at 2.5 meter per second. Now, this is what we generally see across many places. You can see the duct coming out of the AHU, which is fully dirty. And you can see the AHU inside, which is corroded, and a lot of fungus inside the AHU as well. The filters are also having a lot of fungus inside the AHU, and the grill or the outlet is also corroded, or it has got fungus in it. All this is basically because we do not have a proper maintenance team, or we don't have the facility to maintain. Sometimes we put AHUs in places where you can't maintain them. You cannot have a door that cannot be opened. So you can see this is the kind of systems that generally we come across, and we should avoid that. So we should have a proper team to actually make sure that these systems are clearly maintained at all points of time. Now let's go into the maintenance part. We need to have a planned preventive maintenance for the air handlers. And for all such critical areas like your OTs and the ICUs, we need to have a PPM frequency of 30 days. Otherwise, we're going to be in trouble, because whatever you saw in the previous slide is going to happen inside your AHUs if you do not have a proper preventive maintenance done at the intervals of 30 days. Okay, so we need to maintain you need to have a planned preventive maintenance for the whole year for all your theater AHUs and ICUs. Then you should have a proper checklist, which you actually utilize at every point of time. Every point of time in the sense that whenever the maintenance is being done, all these points are supposed to be checked and monitored, so that you don't have a problem with the AHU, and the AHU doesn't fail or it doesn't give a lower performance, thereby you removing the problem of cooling or air filtration or even positive pressure inside your theater. So please maintain this checklist when the technician visits the AHU every month, and make sure that he checks everything on the AHU. The electrical parts have to be checked. You have to check both the filters in the AHUs, check for any leakages on the AHUs, see if there are water dripping, whether the drain pan is clean, whether the drain in the water drain in the pan is flowing through the drain and going out into the building, so that there is no water stagnation. See, water stagnation is also a problem, because it will create contamination. So the water that is dripping from the coil onto the drain pan has to be quickly going out into the main drain line and out of the building. So check whether the drain pan is correctly sloped, whether the water in the pan is also being drained out. So this checklist is mandatory. Every maintenance check has to have this checklist properly used by the team. Common errors that what we normally see is that when we select the AHUs, we look at lower budgets, and that will end up giving you the wrong product. Second is the design is wrong, and then you compromise the design and you compromise the selection in the selection of vendors also. The correct vendors are not being chosen. Why I'm telling you as a vendor? Because there are vendors, most of the vendors are people who manufacture AHUs for commercial applications. Many of them are not making AHUs specific for healthcare. For healthcare, to make such AHUs, you need to follow the specifications. So these AHUs definitely will be costlier than your standard commercial air handlers. So the way of looking at lower budgets, you will end up purchasing a lower quality air handlers, which is not fit for a hospital or a healthcare facility. Another important point is the use of variable speed drives, because the air handlers for operation theaters or ICUs are generally not to be switched off. They need to be running at all points of time. So to maintain temperature and pressure and humidity control inside the theaters or ICUs, you need to keep the AHUs running. But you need to still save some energy. So you need to change your starters from normal DOL or star delta starters to variable frequency drives, wherein you can set the speed of the AHUs for the daytime for a particular speed where the cooling is required for these surgeries to happen, and the night time when the surgeries are not happening, you can reset the temperatures as well as check or reset the speed of the VFD to a lower speed, so that the pressure in the theater, the temperature in the theater is still maintained to a temperature of around 21 plus or minus 1, and you have a good level of contamination control. Okay, and also the use of heat recovery, because since we are bringing in fresh air into the building, we also need to actually throw the stale air out of the hospital. So there you need to use a heat recovery system, because this heat recovery is what it's going to do is it takes the energy from the air which is going to be thrown out of the building and cools the fresh air coming into the building. It's basically recovering the temperature from the air that's going out of the building. So though these heat recovery builds are slightly expensive, but over a period of time, you will get the return of investment because of the saving of energy. Because when you look at your electricity bills in the hospital, the cost of running the air conditioners is the highest in terms of the electrical consumption. So wherever possible, heat recovery, wherever possible, using speed controls for your AHUs will bring in lots of energy savings for the system. Okay, so I come to the end of this section of the air handlers, construction, how to operate, how to maintain them, and how to actually take care of your selection so that you do not have a problem of maintenance or a tripping or a breakdown issues with the AHUs, because one theater can have only one AHU. You cannot, no system says that you should have a standby AHU. That's how the design is going to be. So when you select them right, so that you don't have a problem. Midway through a surgery, if the AHU fails, you know what's going to happen. It's going to be disaster, because in most of the cases I've seen, if you have 5 theaters, during the peak hours, all the theaters are going to be full, and it's going to be a big issue if one of the theaters, the AHU is going to fail or is not performing to its requirements. So I come to the end of the session. Thank you for giving me this opportunity. Now let's go through the question and answers. Thank you.
Thank you, Mr. Vinod, for the wonderful session. I think this is a very useful section, and most probably the timing may not be enough. Okay, it's a vast area, but you have covered a lot of things, including standards and the maintenance part in a very short time. So there are few questions.
Yeah.
How many times we have to service an AHU? I think you have answered that.
Yeah, 30 days.
Yeah, 30 days.
Yeah.
Okay. Again, there is a question from Radhika Shankar. How many times air changes for 1 hour?
Okay. Now for the theaters, as per the standards NABH talks about, is the fresh air is supposed to be 4 air changes per hour, and the overall air changes is minimum 20. So 4 air changes is going to be the fresh air, and overall air changes is 20 air changes per hour.
Okay. Next question is Vanita Girish. Sir, can you explain about power saving strategies in HVAC?
Yeah, I just mentioned this again.
Yeah.
See, first of all, the selection of the right product itself will not bring in issues with energy. Why? Because if you go to many of the right now, all of you go to your AHU rooms, you can see air leaking through the AHUs, and there's condensation on the AHUs. Both this is going to be energy consuming, because when there is leakage, you're cooling the air, you're filtering the air, you're doing everything, and finally you're leaking it through the AHU itself because it is not the correct AHU or it's not maintained correctly. So what happens is energy saving can be done if your leakages can be stopped. Then all the AHUs, 90% of the AHUs, you can see condensation on it. Why? Because the AHU selected is wrong, because the insulation thickness inside that is not correct. And when I talked about a factor called TB2, which is the thermal bridging, if you have that AHU with that factor, you're going to stop this condensation. Condensation means you're losing energy. Okay, then as I said, theaters and ICUs, you cannot switch off the air handler, so it has to be run on a VFD, variable frequency drive, where you can have a small controller. You can tell the surgeon or the people handling the theater that from morning 7 to evening 7, the AHU should be running full speed, and during the night times on the holidays at 50% of the speed, you save energy. At the same time, you still cool the theater, you still maintain temperatures and humidity levels at the lower speed also, because nobody's there in the theater during the non-surgical hours. In the ICUs, another question, like you said, at least 2 air changes per hour fresh air is needed for the ICUs, 12 air changes for the overall.
Okay, thank you. The next question is, when the filter should be changed?
Yes. Now for the filters, basically, what happens is the filters are clean when it comes, but over a period of time it gets clogged. Now there are 2 kinds of filters that you see in the AHU. One is a pre-filter and one is the fine filter. Now what we normally do is that we have the, can I share the screen once again?
Yes.
Shown the pressure levels. I will just tell you the pressure levels. Actually, what happens in the filter case, what happens? The pre-filter is one that is washable. Normally, it's of a kind of a synthetic media that is washable easily, can be used. And when you go for a back filter or fine filter, it's not washable. You can only dust it using a blower or a vacuum cleaner. But then generally what you do is you have pressure gauges, differential pressure gauges, which you actually install before and after the filter. As I said, pre-filter one, back filter one. You put the differential pressure gauge before and after the pre-filter, and you put another pressure gauge, differential pressure gauge, before and after the fine filter. Okay, I'll share the filter level, pressure levels right now. But this pressure gauge, differential pressure gauge, what it does is it measures the air passing before the filter and after the filter. Okay, otherwise it's difficult to notice what pressure level is there and how you change the filter. The primary important part is that looking with naked eyes, you'll not be able to see that. You will only be finding the problem when the doctor says air is not coming. That's the end of life of the filters. It should not be the case. So here what we do is we have the differential pressure gauge for both the kind of filters, which will measure the pressure of air before and after. So when the air pressure is after the filter is reducing, it will tell the values and give an alarm, or it can be connected to an automatic system which tells you what pressure levels are, according to which the maintenance technician notices the department to buy new filters and go for a replacement. Okay. Generally, for our continuous use, you will look at it as a minimum 6-month period to 1-year period based on the kind of usage, the kind of maintenance that you do in your building. Because when you allow the AHU to leak, when you allow dust or other outside air to come into the AHU, then your filters get choked very faster. So there is no literal timing, because if you feel that the pressure level is going to be dropping because the filter is choked, it is time to replace the filters. Only thing is, a pre-filter can be washed, but the other one cannot be washed. The G4 can be washed, not the F9.
Thank you.
Next one.
Next questions. Few questions you have already answered. It's from Dilip Kumar. What are the things to be checked for a quality manager daily?
For the theaters, okay. On a daily check, for the air handlers, if you look at it, they need to look at the condensation on the surface, any vibration. Then they should look for any air leakages through the outside or inside of the AHU, because there are 2 sections of the AHU. One side of the AHU is high pressure, and one side is low pressure. That has to be checked. And next is, as I said, when you have the pressure gauges for the filters, check the pressure level. So you need to have a small checklist made for the quality team, which they can actually utilize to tick and then find out if the AHUs are being maintained correctly or if they're having any problems. And above all, when you come into the theater, you need to monitor your temperature, you need to monitor your humidity. The temperatures as such is 18 plus minus 3 degrees. And when it comes to humidity, it's acceptable to have it around 55%, not exceeding 60%. When it comes to the positive pressure of the room, the operation theaters generally have to be maintained at a positive pressure of plus 2.5 Pascal or more. And as per CDC guidelines or AHU guidelines, they do say you need to, it's recommended to have 8 Pascals. Why? Because people keep on opening the doors continuously or during the surgery for various reasons, which in my suggestion is that try and avoid opening and closing the doors, because it releases the positive pressure and you come closer to a negative pressure where infiltration will happen, and it is going to contaminate the air inside the theater. So plus 2.5 Pascal inside the theater, below 60% humidity, and temperature around 18 to 21 inside the theater during the surgical hours. These standards can be used as reference and references, and the monitoring team can use it to monitor.
Thank you.
Yeah.
The next question, this one I even wanted to ask, how we can clean microbial growth within duct of AHU?
Yeah. You know what happens is when you have these systems already in place correctly, it will reduce all that because filtration levels happen. One more thing is we can, which I have not mentioned, is we can use UV lights inside your AHU. Okay. The UV lights is kept just before the chill water coil, which actually the light will be beaming on the chill water coil. Now it actually cleans and disinfects the coil of any kind of bacterial or fungus growth happening from the AHU side. So further down the duct and down to the HEPA filters, it gets reduced because you are killing them straight away where it is being generated inside the AHU. The next is there are duct cleaners, robotic systems that can be utilized to have robots going into the ductwork to go and clean the system. We do regularly basically. So what is important is as part of your maintenance, when you as I keep on saying, the right product is the first thing that will actually disseminate all these problems inside the duct or fungus issue inside the, the HEPA filters, which is the last one before the air comes into the theater. So when you have proper filtration in the AHU, and when you clean your coils also, obviously the duct doesn't get clogged with this, HEPA filter is also safe. So it's a combination of the right product and right maintenance. And if you have an existing problem, then you need to make use of robotic kind of cleaning to clean the inside of the duct. It's a very useful system. You can do that. If they want, we can share the details of the people who do that also.
Thank you. The next one is an interesting question. We are in a setup that has been running in long while, and we find few aspects aren't met. How do we correct this infrastructural gap from the requirement?
Okay. See, it's the gap analysis has to be done. Number one, what is the standard asking for and what do we have? What can be done is you need to look at the gaps as short closing and critical ones that can be short closed, and the less critical ones to be taken for a longer time. Because what happens is a major shutdown definitely will cripple the theater because you'll have to stop surgeries. So you need to look at a system wherein the gaps have to be first identified. You need a good person to identify the gaps. Once you know what the gaps are, like when I say you don't have a pressure gauge to monitor the pressure difference across the filter, and you don't know when the filter is getting choked. Now installing this pressure gauge doesn't need any time. You can do it post-surgical hours. Okay. Similarly, replacement of filters, you do it. You have a maintenance on every month, one day you will dedicate for the maintenance. When you do the maintenance, many of them can be done. But when you say that you need to change the coil because it's not cooling, it's a major challenge. Because the AHU selected was for 6 tons, whereas you need 10 tons. So the doctor is not getting the cooling. So how do you make it? And how do you do that? It's going to be a shutdown. There is no other way, because you need to throw away the other AHU and bring in a new AHU, because that AHU, you cannot fit a 6-ton AHU with something and make it cool, give you the temperature in the room, because you need 10 tons. So the option is only to remove that AHU totally and then replace it. So we have to look at a full, full shutdown versus a minimum shutdown or a weekend shutdown, which you can utilize it for the small works to major works according to the criticality. But definitely meeting standards is important. Otherwise, the hospital acquired infection is going to start from your AHU, which generally gets ignored.
Thanks for that, Mr. Vinod. And the next
Yeah.
question is, can we use standing air coolers in wards where there is no AC? I think that the hospital has to decide, no?
In which place?
Or
Where do they want the air coolers?
in wards.
Wards.
Yeah, yeah.
The air coolers, I mean, air coolers generally are not a good choice because air coolers cool the air using water spray. Okay, so there is a water medium inside the air coolers, and there is a tray which holds the water. Any kind of water is basically going to bring in infection or contamination. So air conditioners don't have that issue. You are actually throwing away the water in air conditioners, but in an air washer, air coolers, you're putting the air into the room, which is not correct. Unless it's a hospital which is in a very dry place where the humidity is already below 40%. But using for clinical applications generally is to be avoided because air washers or air purifiers are not the right method to use, even if it's a ward, because it's going to contaminate the air.
Yeah, thank you. Next question is, what is the exposure time for UV light?
See, if you have a UV light inside the AHU, there is no problem because it's inside an enclosed AHU and it's going to be running. As long as the AHU is running, the UV light will be running. When the AHU technician is going to maintain the AHU, is going to open the access door and go to maintain the AHU, at that time what happens is you will have to switch off. That there is an automatic switch off there. But inside the room, definitely you will not use it when somebody is there inside the theater. It's to be used only during non-surgery hours when nobody is available.
Thank you. And many people are asking for the robotic cleaner details.
Yeah, we will share that. Yes.
Yeah. Okay. Then I have one question.
Yes, sir.
So how do you maintain humidity in theaters along with the AHU? What is the best solution for that?
Yeah, what is happening is generally the AHU selection is the primary design factor which will bring down the humidity to a larger extent. The coil, which I talked about, the cooling coil, is supposed to be the one which actually starts the dehumidification process. Removal of humidity is called dehumidification. So the dehumidification process happens inside the coil. Okay, that's where the water condenses, it goes to the drain pan, it goes out. So you're actually trapping all the humidity, throwing it away. So as I called about, the coil should be deeper row coils, because deeper row means the coil has got number of rows of copper tubes. What happens when generally is, when for healthcare applications, we generally specify 8-row coils in the sense for such application, because the more the coils in the AHU, more the tubes in the AHU, the time of the air spent inside the coil is more time. The more time the air spends in the coil, more water gets condensed and it goes into the drain pan. So there's a lot of dehumidification happening across a deeper row coil. Number one. Number two, since we talk about 4 air changes per hour, you need to bring fresh air. Now, when it is raining or when it's in a coastal area, you're bringing in fresh air, which is almost like 100% humidity, and you're mixing it with the return air. So we have a mixed air right now. This mixed air generally will have a higher humidity, as close to 80 or 90%. Now you have to use dehumidifiers generally, which are generally expensive. Number two, we use heaters. We call them as reheaters. These reheaters are basically used to control your humidity. So you can have the heaters inside your ducting or inside the AHU itself. So that will actually control the humidity. And that will be controlled by using a system or sensor called a humidistat. And there's a safety feature there, Arul, is the heater should not keep running for a long time. It will heat the air. Hot air will go into the theater, which is going to be dangerous. It could be a fire situation. So you have to be very clear with your controls when you put a heater. The humidistat should also be having, along with it, a thermostat. Suppose the humidistat is not working. Humidity is achieved, but the heater is continuously on. You're going to have a situation of a safety of fire. So this thermostat will sense that the air is getting heated up and it will switch off the heaters. So this kind of safety measures are important when you install the heaters. So dehumidifiers or using reheaters will actually control your humidities.
Oh, thank you. Thanks for the clarification.
Yeah.
And there is one question. What is the cleaning protocol for HEPA filter in OR?
HEPA filters, there is no cleaning protocol. Yeah, see what happens is you need to do a validation once every 6 months or at least once in a year. Don't go beyond that. And the calibration process will tell you the kind of particles that are being trapped or not being trapped, or the filters are being choked. So that will actually, the calibration details will tell you that you need to replace it. It's a replaceable. The fine filters and the HEPA filters both are to be replaced. There is no way of cleaning them, number one. Number two is, suppose you get a growth and you feel that there is a problem because of the HEPA filters, you need to get the HEPA filters validated the time you get a growth immediately, because don't wait for the 6 months or 1 year time period. Standards talk about 6 months for the validation. If at all in this first month to 6 months you find there is a growth and it's through the air, and when you open the plenum you see that there is fungus on the filters, please ask them for a validation, go for the replacement, because it's going to be very critical for the patient.
Thank you. Thanks for the answer.
Yeah.
And the next question. Do we have to have a dedicated AHU for minor OT?
Yes, any theater for that matter, even if it's a minor procedure, it's always better to have a dedicated one. Because what happens, procedures do bring in contaminations, and if you're going to connect this theater to an OPD, obviously you're going to contaminate the space in the OPD as well. If in that case, it's not the right practice. So an OPDs need, see, a minor OT still has to have an AHU with a fine filter and a pre-filter. But for an OPD, for example, doesn't need a fine filter, it just needs only a pre-filter. A normal air conditioning FCO is enough for a normal OPD. So you don't need to mix the air or connect a minor OT AHU with another space. You need to keep it individual.
Okay, thank you. With one more question, we will finish the session as we are end of the time. Do we have to have separate HEPA filters for each OT?
Obviously, every theater should have its own HEPA filters because every theater is separate from each other, and each theater will have its own air handling unit, its own air distribution system. And when you have the HEPA, it should be separate.
Okay, thank you. Sir, there are no more questions. So I think we can finish the session. Thank you, Mr. Vinod, for the wonderful session, wonderful starting of this Healthcare Engineers Forum. And I thank all the participants. And I hope you have learned a lot today and your questions are answered. So please stay tuned with us, and there will be many more sessions coming in the future in this Healthcare Forum. Thank you.
Thank you, Arul. Thank you, CAHO, and thanks to all the participants. The participants make our day, basically. Thank you.